We will now proceed to the next section, which is about dynamic arrays. A dynamic array is an array whose size is determined when the program is running, not when you write the program, as we usually did. Talking about pointer variables and array variables are actually pointer variables, and that point to the first indexed variable. Lately, we've been using arrays, but of course, at that point, we still haven't realized that array variables are actually considered as pointer variables. Here's an example which shows the scenario. In this example, variables a and b are the same kind of variable. Since a is a pointer variable that points to the first index of the array, the following statement causes p to point to the same location as a. Continuing the previous example, pointer variable p can be used as if it were an array variable. Here's an example. Variable a can be used as a pointer variable, except the pointer value in a cannot be changed. Here's an example. In this case, we declared a pointer variable p. Then, we declared an array of integers with 10 elements. In this case, we performed the following loop. In this case, we are simply assigning values to each index of our array, numbered from 0 to 9. Then, we simply assign that array to this pointer variable. At this point, we would like to output whatever is the content of our pointer variable p. And if we are going to run this program, this is what happens. As you can see here, we simply transferred or copied the contents of our original array variable a to our pointer variable p, as you can see here, which makes pointer variables or array variables work similar to that of a pointer variable. Now, how do we create dynamic arrays? Normal arrays require that the programmer determine the size of the array when the program is written. In our previous lessons, that's how we usually create our arrays. We need to first specify the number of elements that our array should contain. But the problem is, what if the programmer estimates too large? Which means a lot of memory space could be wasted. On the other hand, what if the programmer estimates too small? As a result, the program may not work in some situations when the array gets full. Dynamic arrays, on the other hand, can be created with just the right size while the program is running. To do this, we create dynamic arrays by using the new operator. Here's an example. We would like to create an array of 10 elements with type double. To do that, we have the following. As you can see here, we declared D as if it were an ordinary array, when in fact, it is actually a pointer variable. After we use an array, it should be deleted to return memory to the free store. That's what we have learned from the previous section, which is about basic memory management. Here's an example. We would like to delete the pointer variable D, hence freeing whatever memory it used when it was running. In this example, the brackets tell C++ a dynamic array is being deleted, so it must check the size to know how many index variables needs to be removed. Here's another example. In this case, we declared the following functions. And of course, same functions will be used in our main function and with the following declaration and definition. Let's try another section. We also have the concept of pointer arithmetic. As we can see here, we can also perform arithmetic on the addresses contained in pointers. Using the dynamic array of doubles, previously we declared the pointer variable D, which points to the following index location, and later on will also be used to contain an array of double. In this case, the expression D plus 1 evaluates to the address of D1, and of course, doing this arithmetic operation will also result to pointing to whatever value is contained in the following index at D2. Notice that adding 1 adds enough bytes for one variable of the type stored in the array. Hence, as we can see here, we can simply move up our pointer variable, which is actually an array, by simply incrementing the index number that we have. Aside from that, we can also perform subtraction with pointers. As we've seen a while ago, we have used add to increment the index number that we would like to reference. We can also use the minus operators or the decrement operators. Two pointers of the same type can be subtracted to obtain the number of index variables between. Of course, the pointer should be in the same array. Here's another example. As we can see here, although we don't know what the exact address of a certain value is, but of course by the use of pointer arithmetic, we can simply go up the array and access whatever value is stored in the index that we are referring to. We can also use multi-dimensional dynamic arrays. Of course, we can in the previous lessons we were able to know what multi-dimensional arrays are, and we can also do the same using dynamic arrays. For instance, we would like to create a 3 by 4 multi-dimensional dynamic array. We can look at multi-dimensional arrays as arrays of arrays. First, we need to create a one-dimensional dynamic array. We can do that with the following. First, we need to create our own type definition, which is a pointer variable of integers. Then, we create a dynamic array of pointers named as such. In this case, we would like to create a pointer array of three elements. And of course, the next one that we will create is an array of 4 elements. For each pointer in M, we create a dynamic array of integers, which will now comprise our other dimension, which is comprised of 4 elements. Simply put, we have a multi-dimensional array of 3 rows and 4 columns. Hence, the dynamic array that we created on the previous slide can be visualized like this. Now, how do we delete multi-dimensional arrays? To delete a multi-dimensional dynamic array, each call to new that created an array must have a corresponding call to delete. For example, we would like to delete the dynamic array created on the previous slide. Thus, for each call to the new operator, there should be a corresponding call to delete, as we can see here, which would delete the array that we created in the previous slide. Here's an example. As we can see here, in this part of our source code, we created an array of integer pointers using the new keyword. And of course, we used that array, we assigned value to it, and we also output the value of those arrays. After we use the arrays, we need to delete what we created for the purpose of freeing the memory that we used, thus returning the memory to the free store. If we are going to run the program, we have the following. For you to explore this example, a source code has been provided to you, which shows how it works. Here's the example. In this section, we were able to learn how to create our own type definition, which in this case, we use for declaring pointer variables. We were also able to write codes, which enables us to create arrays, and to be specific, arrays that can be created dynamically. Hence, we have what we call multi-dimensional dynamic arrays.